All right, let's look at the last exercise here. So you have e to the x at 1 minus e to the 2x, and that's radical. So again, remember that we're trying to catch some of the squares or different squares. So one observation here is that e to the 2x is e to the x quantity squared, right? So that makes this term to be 1 squared minus e to the x quantity squared. Okay? So it's a number squared minus e to the x squared. Okay? Well, let's do this first, since we have this observation here. So why don't we call u to be e to the x to start with. Maybe we can get rid of this e to the x in the next step. Okay? So if we do it, du equals e to the x dx, and this integral turns out to be 1 minus u squared du. So this is a relatively simpler integral to work on, and we have a specific transformation for that because it's 1 squared minus u squared, right? 1 squared minus u squared. So I'm going to call u to be sine theta. So I'm going to call now u to be sine theta. Okay, let me use a different color. I'm going to use u equals sine theta, and du equals cosine theta d theta. Okay? And 1 minus u squared is 1 minus sine squared theta, and that is by the Pythagorean theorem. So you have cosine squared theta here. Now let me just put my right triangle here. Okay, sine theta is u, which is opposite divided by hypotenuse, right? So opposite divided by hypotenuse, u over 1, right? So that this side is going to be hypotenuse squared minus the other side squared. 1 minus u squared, essentially. Okay? All right, so this integral turns out to be 1 minus u squared is already cosine squared, and we need the radical of that. So that's cosine theta. And du is cosine theta d theta. So this in turn becomes cosine squared theta d theta. So when you have an even power of cosine, we use the power reducing formula for cosine squared as the way we got in part C. Okay, and then this is now integrable. So it's 1/4 sine 2 theta plus theta over 2 plus c. Okay. I think we're all done with the integration. Let me just double check everything. Yes. So now I'm going to back substitute. I'm going to clean this part. We don't need that anymore. I'll continue with blue. Okay. So first of all, sine 2 theta is 2 times sine theta cosine theta. That's the first observation because the triangle is set up for the angle theta, but not 2 theta. So we have to use a double angle formula to simplify that. So it's 1/2. Sine theta is u over 1, which is u. And cosine theta is 1 squared, which is 1, right, minus u squared. So in other words, 1 minus u squared. That's radical. Okay? Plus, well, theta is already coming out of this. That is sine inverse of theta, or arc sine theta, plus c. And we have to keep substituting back. Let me erase this part. I don't need this anymore. So all we need to back substitute u, okay? So 1/2 e to the x, 1 minus e to the 2x, which is the square of e to the x, right? And then 1/2 theta is, let's see, I should have kept the transformation here, u equals sine theta, right? And theta equals sine inverse. This is u, I'm sorry. This should be u. Okay, so let me just use a different color. Okay, this was U. All right, so it's 1/2 sine of sine inverse, right? And U equals e to the x plus c. All right, I think that takes care of everything. Yep. All right. So if you have any questions or comments, please send those to my way. Thanks for watching. I'll see you in another video. Bye.